All right, what's going on, everybody? We're here in Columbus, Ohio for Stir Trek. I'm in a theater, and we're gonna do Better the Devil You Know sequel. Make some noise! Yeah! We're gonna get it started.
Like and subscribe.
That's right, like and subscribe, leave a comment, do all the things, interact, follow me on the socials. It's interesting because right now we're in a literal theater, and most of the time when I give these talks, I'm in like a more traditional like conference place, and I worry about yelling too much and then the next door room will hear us screaming. But not in this instance, not in a theater. This is really, really cool. So you are here for Better the Devil You Know sequel, a ghostwriter story of database paradigms and vengeance. Today, we will make a Faustian bargain as we do our battle with the devil. So it all began with me submitting my soul to the NoSQL way of doing things. I had built my first production systems on DynamoDB. It was fast and forgiving, and at the time, to me, it felt like freedom. I didn't have to manage migration scripts. I never learned SQL when I got started, and I didn't need to worry about partitioning. Kind of Amazon, AWS just sort of did it for me, and it gave me the tools that I needed. I learned how to work with single table designs and complex composite keys, which we'll get into in a little later. But I also wanted to mention how NoSQL became just a brand new category for everything that isn't SQL. What I found is when I started learning this stuff about 10 years ago, I just started with NoSQL. And SQL at the time was just way too complicated for me, but NoSQL databases were exploding at the time. Things like MongoDB, and then other NoSQL databases like columnar stores, vector stores, time series, and graph databases. And to make it even more confusing, a lot of NoSQL databases will offer a SQL compatibility layer, so you can still kind of write your SQL queries against a non-SQL database to make it even more confusing. But over time, the freedom that I felt, it really started to become a boundary. DynamoDB could handle my scale, but it really wasn't designed for deeper analysis. I got speed, but it came at the cost of insight. That's when I hit a wall, and I felt lost. I had been using the same database for 7-8 years. Should I continue to dive further into what I know, or should I take a chance and discover new wisdom? For that decade, I want to share with you that my programming journey has had one constant presence: Nicolas Cage. I turned to the wisdom of Cage in this instance, and I got inspired by his work in Ghost Rider. Now, in the movie Ghost Rider, Nicolas Cage plays Johnny Blaze, a motorcycle stunt rider. He sells his soul to the devil in order to save his father from dying of cancer, only to be deceived by the devil when his father dies in a tragic motorcycle accident a day later after being cured of cancer. Like Johnny Blaze, I made a deal for power without understanding the true cost. I sold my soul to DynamoDB and NoSQL databases because it was the first one I came across. It was the one people were willing to train me on. So I was chasing performance and simplicity without realizing what I had been giving up. I thought I was comfortable thinking I only needed just the one database. The need for SQL was coming for me. And it was coming with a vengeance, just like Ghost Rider. So, in 2024, AWS released Aurora DSQL. Stands for Distributed SQL. It's we're going to talk about what it is. It felt like a path to redemption for me. It gave me a way to bring structure back without losing the serverless flavor that I had become accustomed to. Previous SQL databases from AWS weren't really serverless. They didn't spend down to 0. They had a lot of restrictions, and they weren't as nice to work with. The SQL query power to structure the relationships was something that I was just used to flattening in DynamoDB. I'd say that Johnny Blaze was seeking vengeance for the devil's deception, and I was seeking balance for my SQL inequities. And Aurora DSQL offered me a way to face it. And what I wanted to tell you all about was that my work with SQL wasn't because I needed faster performance or I needed better uptime. It was about working with the data just completely differently. So what DSQL brought me was this distributed scale. When I'm used to working in Dynamo, the operating model is serverless. So that means I'm not dealing with like database passwords and connection strings. I'm just using the Dynamo SDK, and when DSQL came out, the DSQL SDK. I always thought it was crazy whenever I had to connect to a production database that the only thing keeping that application out of the database was literally a connection string and a password and a username in some text that you're sending through. You could call it dynamically, like at runtime from a secret store, but it still didn't feel right. With DSQL, because it's built brand new, they were able to put IAM restrictions on that connection. So the cool thing for me when I was using it is that when I create a DSQL client, I'm getting a fresh security token every single time, and that connection is driven by IAM security. So it just already feels a lot more responsive, and I don't have to worry about managing actual database passwords and database secrets. The 3 lessons that I was getting, or correcting my ignorance for SQL revenge, bringing some justice to my overall data knowledge, and learning how to sacrifice a little bit of the speed that I was used to from Dynamo. Now, Aurora is actually an interesting technology. When it was released, I dove into the YouTube videos about the actual architecture of it. And for all the terrible things that Amazon does, AWS itself really does only try to make stuff that solves a customer problem. And I was that customer, so used to doing NoSQL stuff that I needed a SQL. I didn't know I needed a SQL solution, and they had built it in DSQL. So what they did was they took Postgres as a monolith and they decomposed it into a bunch of small microservices. Those small microservices are what allows AWS to serve this database program completely distributed. There's, 5 separate parts: a router, a query engine, an adjudicator, a journal, and a storage engine. Those are the main parts that they'll talk about and how this thing works. But the one in particular that I was interested to learn about was how they created DSQL all around a very precise internal clock system to AWS. So with a more monolithic traditional SQL database, you're locking all of the rows of the tables to prevent, one transaction from overwriting another. With this system, what they've done is they've attached a very precise time measurement to every commit, and so there will always be a winning commit in time. And what that allows them to do is they call it optimistic concurrency, where over the entire global scale, your writes aren't going to conflict with each other. It's always going to be based on a synced up time thing. And that synced up time thing belongs to like the backbone of Amazon. What was also interesting to learn was that GCP, Google's cloud service, has had a similar architected database since like 2012. It's called Google Spanner. It's also a time lock commit-based distributed SQL database. So when Amazon came out with this 2 years ago, I was like, oh, this is really cool, brand new stuff. But it's really not. Google has a version of it. But because I am more comfortable in AWS land, this is what I decided to really dive into. All right. You know, I like this quote, anything's a database if you're brave enough. Does anybody here follow the podcast Screaming in the Cloud with Corey Quinn? It's like cloud stuff. All right, well, he has always had this saying where like anything's a database, even including like DNS records. So he had built this POC where he used Amazon Route 53 DNS records as a database, because if you can look up an endpoint, set and get some data, you have a database. And DynamoDB taught me to move really fast. It thrives on iteration and clarity of purpose, and it's built for known access patterns. But when I need to join data or analyze trends, I have to shift all of that work into a separate pipeline. I was used to storing data in Dynamo and then copying that data into something like S3 that I can query over with Athena. But when DSQL showed up, it shifted my mindset, and it showed me how to handle joins and aggregations. And then I started realizing that maybe it's not like SQL versus NoSQL. It's not a rivalry. I'm just using the devil's own power against itself to be able to handle both of the paradigms. Databases are hard. Really hard. And not only are they hard, they are scary. This is because the database is the literal customer value. The first time I worked on production systems, it was with fast-changing user data. It was account information that was monitoring users in real time. And it was terrifying to get wrong. DynamoDB was a choice that was already made for me. I felt like I was missing out and I had no time to pursue other options. But I realized that databases will continue to change and evolve, and I noticed that vendors move in cycles. They make things simpler with new abstractions, but then those abstractions make the entire system a little more complicated, and then they'll hide it again by making it simpler again. So I've been through this evolution with just databases. Just between DynamoDB, this NoSQL key value store, and Aurora DSQL, a split apart microservices Postgres engine. With DynamoDB, the system seems simple. It's just keys and items, but that simplicity pushes more complexity into the application layer. Now in my actual code, I have to handle more of the data logic. But when DSQL shows up, it's kind of the opposite. DSQL allows you to run this data logic inside of the database so that you can do your joins across your tables. And now the system is handling like global ordering and distributed transactions and even time synchronization. So my lessons from figuring out these databases is that no one single way is actually like the true path forward. To understand the strengths and the trade-offs of Aurora DSQL, I'm going to show you something that I built from fitting for Ghostwriter. It's a soul contract manager because even when your work involves reaping souls, you still need to have good record keeping. And I'm sure the devil has a very good accountant. So Ghostwriter definitely needs a soul tracking contract software system. Okay, so this is the scenario. Ghostwriter's going out, he's reaping souls. I've seeded 2 databases, one DynamoDB and one Aurora DSQL with 1,000 souls, and across those 1,000 souls, they've got 10,000 events and 5,000 ledger events. A ledger event is the thing I made up where as soon as Ghostwriter comes and signs a soul under contract for the devil, it has some power amount. It's like a supernatural dollar amount. So these are the events and the data that I'm stuffing into these databases for my tests and for my examples. I guess show of hands if you're already kind of familiar with DynamoDB. Okay, cool. Show of hands if you're more familiar with SQL stuff. Okay, very good. This is what I wanted. I wanted a whole bunch more SQL knowledge because I am new to it. And what I'm going to do is spend some time to show you what NoSQL is like so you can see just how insane I am, and then I can understand how insane you are and how it's really just the same stuff, just a little differently. All right, here we go. So this is the data model for doing a single table design in DynamoDB. DynamoDB, like I said, is a key value store. So you can just think of a 2-dimensional spreadsheet like we have here. And the cool kid way of doing it is overstuffing these tables with semantic meaning using what they call a complex composite key. So under PK, that's primary key. This soul ID number, it could be like soul tormented prison 0025. That would be the same all the way down this column. And on that primary key, you can then look up contracts, events, or ledgers. All of this is within one table. Your whole application is just slamming against this one table. And the speed of your queries comes from knowing the exact primary key and the exact sort key that you want to find. And what you're going to end up doing is writing all of your properties and your attributes all along a single row that you can think of as essentially going on forever. You can stuff this row with as much data as you want, and you'll get consistent query return speeds on it, no matter how many rows of data you have. Well, that's not technically true. You could have lots of rows of data, but it will go down that one row consistently fast all the way to the end and bring back everything. So that's what I mean by the data is flattened. That's what I mean by saying the data is denormalized. We're actually rewriting all of this data over and over again into a single row. Okay, that's Dynamo. Now, for the SQL stuff, this is probably more familiar to you. It's 3 tables, nothing too crazy. We have primary keys of the IDs, and we're going to join on these foreign keys with the sole contract ID. So there's still 3 like entity tables, the contracts, the contract events, and the ledgers. So it's still the same sort of data, but now we're in 3 tables instead of 1, and now this DSQL has the relational bits. We can jump from table to table. Let's see here. Right. So, what makes DynamoDB so good? It's because we can do things fast and precise, and the cost is cognitive load and duplication when you need analytics. Like I had mentioned before, whenever I got into a point where DynamoDB wasn't good, it was for aggregations. If I wanted to know the sum of stuff, it couldn't really do that. If I wanted to know the correlation between the two entities, doing it inside the database isn't possible. I'd have to handle that in my code. After I've queried the database, I have to kind of stage all that data inside the application in order to make sense of it. I'd have to export the data to S3, which is another block storage service from AWS. And then I'd query it with Athena, which is another service from AWS that gives you kind of like a SQL query layer over top of your block storage, which is handy if you don't want to have to operate a full database to answer some questions over your data. Or oftentimes we would ship it to a totally different team on the data warehouse side. I was working with a lot of transactional data, stuff that needs real time back and forth, and then the production of, well, the results of all that production data, I just shifted straight into a data warehouse for somebody else to handle on a different team. Those were nice. When I could get those meetings and be like, where do you want me to put the data? I'm like, ship it to the data warehouse team. I'm like, all right, it's going to be their problem then. And yeah. Is anybody here on that data warehouse team that receives all the stuff, all the production stuff that I end up just shipping there and not knowing what ends up happening to it? Okay, good. I didn't offend any data warehouse nerds in here. I learned that DynamoDB is designed to be easy for the machine to look up, but kind of cumbersome for people. So if I go back, this looks normal for people, right? Like we can think of this spreadsheet and we can think of the relations between these entities. This right here, this is like Sears catalog part numbers. Like none of this makes sense. But for the computer and for the application, this is a direct map to everything it needs to know within a single lookup. That's the power of these key value stores. So we bring back, that's DynamoDB. Now, with DSQL, DynamoDB is that ledger. It's like instant, fast, but you got to know what you want ahead of time. DSQL is more of like a grimoire. It's got more spells in it, and you have to chain them together carefully to get what you want. Instead of just zapping one transaction in NoSQL land, in SQL we have the expressive power to kind of combine multiple things. And I learned that there was a bit more setup involved with DSQL than DynamoDB, because I had to define a schema ahead of time. With NoSQL, I didn't have to. All I know is that there's primary keys and composite sort keys. That primary key could be anything. We kind of coalesce around an entity plus some UUID, but within that primary key column, there could be many different entities, many different IDs. But with DSQL, I had to define the schema with the data types and then create each table and do migration scripts. It was definitely a learning process, never having done it before. And with Dynamo, the provisioning was just much simpler. But once everything's set up, things start to connect naturally, and I start to see the benefits and the positives of doing things with like ACID transactions, to be able to use the database to do the calculations and the aggregations and the joins on its side. So the way Ghostwriter can take in the contract, update the information on that contract, and insert everything into a single transaction was pretty cool and powerful. Each transaction follows strict ACID guarantees, so that means every part of the update succeeds together or not at all. and it's the difference between a loose collection of notes and a single complete ritual that leaves no room for inconsistency. The reliability comes with extra steps, like generating the IAM tokens and creating a secure connection and managing the distributed transactions. They all take more compute and a little more time. I learned that DSQL trades the speed for correctness. And in practice, what I find is that Ghostwriter can open his DSQL grimoire, run a single elegant transaction, and then it updates the soul's contracts, the log events, and balances the books. It takes a little bit longer to cast, but the result is complete and consistent and easier to audit later. Adopting DSQL was more than a migration for me, it was a reckoning. It wears the face of Postgres, but it is its own creature. Since Amazon decomposed Postgres into multiple microservices, each service layer scales independently while also being distributed. So DSQL is not fully compatible with everything Postgres has to offer, and there are current limitations. It's been in general availability now for about a year, and my colleagues at Serverless Guru, we're having trouble actually finding the best place to use it in production. There's a lot of limitations on DSQL right now, and if previous services show how Amazon's going to tackle it, is that they're going to figure out what the best single workload for it is right now, and then start adding better layers of compatibility. So things that you're not able to do are foreign key constraints. You're only allowed one database name, and there's limits on like the amount of bandwidth that it can handle. It's like 10 megabytes up at a time, and a max of like 3,000 rows. So it has been not the best ergonomics to try and do, like, learn everything and be at the edge of like Postgres best practices, because they are really still trying to find what the best API surface area for them to handle and monitor is for this Postgres integration. All right, so I had sold my soul to the devil for NoSQL. I'd sell it again for some more SQL. And every pact comes with the fine print. Aurora's DSQL serverless design is powerful, but its pricing can turn on you quite fast. Because it's serverless, they've separated the compute costs from the storage costs. So every time you're using compute, making a query, writing or reading, that's all billed per millisecond, just like a Lambda, which is cool because if you're not searching or if you're not using it, then the compute costs go to actually zero. And so the workloads that we're trying to use now are similar ones to serverless workloads when you're just trying out serverless for the first time. You're looking for peeling off edges of applications where you might have seasonal type work where you got to do something maybe just monthly or just quarterly. This is good for those data runs that just sit idle for most of the time. That way you don't have to manage the idle. Intermission. Very good. Does anybody have any questions or comments yet? Not yet. Very good. Okay. I'm going to get a drink of water and remember to stay hydrated. Yes. This is the part where I take my hat off and I pass it around and I ask you all to follow me on social media. This is the QR code that goes to A landing page that goes to links to this repo, links to this slide, links to Serverless Guru. Who is Serverless Guru, you might ask? They are the folks that sent me here and sponsored me to come here. So let's give a round of applause to Serverless Guru. Yeah! Very good. So what do? We are an engineering firm. We do cloud strategy, cloud engineering, and I primarily work on AWS, but we have other folks who are just as strong, just as strong in other cloud disciplines, Azure, GCP. We help enterprises adopt cloud and make it better for everyone. What's really fun is our model is that we show up, we help you with a pointed problem, and we land and expand. We become that cloud center of excellence. And with the amount of change that's always going on, there's lots of stuff that we can do and help with. We're also hiring. So if anyone is interested in doing full stack development, like full stack, like you can deploy the front end, deploy the back end, and wrap everything in CI/CD and do all the database stuff. That's what we do. So come and see me if you're interested in learning more about the positions we have. Our company doesn't have an office. We're just all fully remote, people all around the world working for clients. So along with that, if you go to the link in the QR code, you will also see links for my YouTube channel. In it, I have a video where I turned a salad spinner into a DJ controller where as you spin the salad spinner faster, it plays music faster. When you spin it slower, it plays music slower. And I did everything with JavaScript, WebSockets, and a browser. So check that out. I know that intrigues some of you. Also, you can check out praisecage.com. I have a fanatical devotion to Nicolas Cage and teaching people about web development and cloud engineering. If you go to praisecage.com, actually, what time is it? We got time. Who wants to see if this internet works? Make some noise if you want to see the internet work. Yeah, okay, here it is, praisecage.com. How many people really love going through like web browser standards and web browser API standards? Well, if you do, and you wanted to pair it with a Nicolas Cage movie, then you go to praisecage.com and you could come and find a movie like City of Angels. You view the project, and this one is inspired by City of Angels, and you'll make a Heavenly Scripts angelic font styler. And it's got some sample code, and it'll teach you about the CSS font loading API. Did I know that there was a CSS font loading API before right now? Not really. But we can learn about it, and that's if you just go to praisecage.com. So everyone can praise Cage at any time. And with that, I will come back to the presentation. And I will now invite you all to praise Cage with me. Because in these many years, I have used Cage and his wisdom to clear myself of imposter syndrome, fear, doubt, anything that was holding me back as an engineer. I looked to Cage, and he showed me the way. So on three, I want everyone in here to praise Cage. Ready? Together, on three. 1, 2, 3. Praise Cage. One more time. Give it 1, 2, 3. Praise Cage. Very good. Yes. And if you're in the audience, simulcast, I hope you heard us. I know I felt your praises. So thank you. This is my favorite part. It's praising Cage. It's so good. Yes. Now, let's show you the demo. I was told many times not to count on the internet here. so I didn't. I originally had a different demo. I blew it up this week and redid it. And what I've been doing is I took these two databases, I created them both, I stuffed them full of data, and then I ran a bunch of benchmarks on them. Surprisingly, there was no surprise. When you come up with your own benchmarks, what I've learned is like you'll just end up reinforcing the stuff you already know. But the thing that I did learn was in inserting hundreds of thousands of rows into DynamoDB, it was much faster than inserting hundreds of thousands of rows into DSQL. In doing this demo, DSQL kept timing out. And like the whole point of me doing this talk and investigating and putting time into learning DSQL was to find the rough edges. And I'm so used to Dynamo and how quick it is that I was able to upsert everything and do it in probably like a minute and a half. But DSQL kept timing out, and it had a lot of bulk insert limits, so it ended up taking several minutes, like 2 or 3 times longer, to insert the same amount of data into DSQL. The other thing I learned was that DSQL didn't cost me any money to put all that data in, but for Dynamo it cost me 16 cents. I was like, dang it! They got me. They got me for 16 cents. I was like, that's way too much data. But, you know, that was a sacrifice that I did for the sake of this presentation. But that was what I, like, so what were some of the scenarios that I ended up running on? They were, I don't know if you can even see that. That's way too tiny. So things that you could expect are like reading a soul profile. Like Ghostwriter is rolling up on a soul, about to reap it, and he's got a get profile. The other things that it could do was fetching contracts. And what I've seen here in these charts is like most of the stuff is pretty close. Dynamo is much faster in reading and writing, just straight point-to-point lookup. But then Dynamo sucks at aggregation, which is what we've known all along, right? It cannot pull together like which region of the contracts has the most amount of soul power. It just doesn't do it. It takes, what is that, 9, 10 times as long, but it's never designed for that. So that really wasn't the big takeaway learning lesson. Oh, I wanted to show you this too. This is how the data actually looks inside of DynamoDB. Since most of you here aren't familiar with it, this is the absolute nonsense that Dynamo can sling through so quickly. You see this primary key here, like this one particular row, has all of this information on it, and all I'm doing is looking up a single soul, and then I'm able to find all of the ledger events on it. And that is still so different from how DSQL does it. Okay. So, DynamoDB is the single motorcycle speeding down a single lane. Everything feels straightforward. I have a key, I look something up, and I get exactly what I want for. And I get exactly what I asked for. If I want events for that soul, I use the same key and scan a range of sort keys. Everything in DynamoDB is grouped together, co-located, and easy to access because I've designed it to stay on a single path. But without a direct path, I get into trouble. The data is there, but there's no single place I can go to retrieve it. The landscape of the data is really flat. I can go really far, really fast, down a straight path, but I'm not expecting any turns. Once I moved into SQL, the experience was different. I could start in one table, join another, and then answer a question in a single query. I can take the contracts, join them with ledger entries, group them by region, and then compute a result that spans the entire data set. And that turn isn't magic, it's a join. It's me taking a shared key and using it as a doorway into another part of the data. In SQL, relationships are preserved so I can traverse them later. Instead of flattening everything into one structure, I keep things separate and rely on the system to connect them when I need to. So why can't DynamoDB do the same thing? Why can't it follow relationships the same way SQL does? To answer that, we have to look at what's happening underneath. Dynamo, the data isn't just organized differently. Dynamo is optimized so most queries can be answered with predictable performance and targeting known access patterns within a single partition. That speed is at the cost of flexibility. And it wasn't until I started using DSQL to be able to do more complex queries that I was able to see the difference. SQL systems preserve relationships and allow the query engine to dynamically combine data, which adds coordination across the partitions at runtime. So there's just more trade-offs. And this is where the CAP theorem shows up as a practical constraint. How many of y'all are sick of hearing about CAP theorem? Yeah, one or two. Okay, cool. I gotta sneak it in this one time. Especially in a distributed system where networks become unreliable, you have to decide whether you want to coordinate across nodes to maintain a consistent view of data, or whether you want each node to continue serving requests independently. Dynamo is designed to minimize coordination. It keeps the requests local so they can always succeed even under imperfect conditions. SQL systems make a different choice. They preserve relationships and are willing to coordinate across nodes to resolve them. When I run a join in a system like DSQL, the database is locating data across the partitions, bringing it together and reflect a consistent view. That operation takes more work and it introduces latency and complexity, but it enables something that Dynamo does not, the ability to ask new questions without redesigning the data model. And once I saw it this way, the difference between systems stops being about SQL versus NoSQL and starts being about where the cost of that coordination lives. In Dynamo, you pay that cost up front by shaping your data so that queries can be answered locally. You're pre-joining the data by creating those composite keys and putting all of the data like denormalized and flattened in that same row over and over again. You are the join when you're a Dynamo NoSQL developer. In SQL, you defer that cost and pay it at query time, and you allow the system to coordinate across that data. Seen through that lens, the CAP theorem isn't just about consistency versus availability in the abstract. Dynamo flattens each relationship so that the requests can be handled in isolation, and SQL preserves those relationships so they can be traversed through coordinated operations. With similar operating models, it is actually possible to ride both at the same time. We can ride a fiery horse and a fiery motorcycle at the same time because of the power of the, no, I don't want that. Because of the power of the cheapness of cloud APIs, right? In order to spin up a SQL database, all I have to do is call out to my infrastructure as code, and it's already provisioned, and the security model is all just IAM tokens being vended at request time. So, I think with that, I will finish up right there because lunch is coming up and I want us to have a good shot at getting in line early. So with that, I'm going to finish up here with four big questions. The first one being, did we learn something? Yeah, maybe. Okay. So I break it up into 3 buckets. If you're brand new to this stuff, and did you learn something, my suggestion to you is to grab the repo from the bit.ly. Come see me. You can go to bit.ly/Paulchen Jr., get the repo, get the slides, go through it, deploy it on your own, right? You can use the repo, deploy 2 databases and a full local visualizer to run your own benchmarks. And if you did it the way I did it, it might cost you at most 16 cents if you have to reload the database a couple of times. Okay, if you've been doing this for a while, then I implore you to also go to the repo, download it, try it, see what happens, and tell me if you think anything could be better. I need the community's help to make this presentation even better for the next audience, or if you have suggestions on like database topics that, would make it even better, please let me know. And finally, if you are a grizzled veteran, I hope you consider how multiple database paradigms can change your architecture. What does it mean now that a NoSQL database and a SQL database and a time series database and a vector database, they're all just as easy to spin up as one another? What would having just the right database for your workload right when you need it really mean for you? Also coming soon, my next talk is about adaptation. It's an adaptation of adaptation, where I talk about self-learning computer science the hard way. And we also talk about another Nick Cage movie, because praise Cage. And with that, thank you all so much. I really appreciate you coming out, listening to the talk. And with that, give yourselves a round of applause. Yeah.